what do we know for efficiency here? Efficiency is going to be work output over work input times 100, right? Now, because they gave it to us in terms of the percentage here, what we want to do is we want to we could change that 78.5% to 0.785. Now, let's talk about this. Work output is going to be the resistance force times the resistance displacement over the effort force times the effort distance. Okay? Because effort would be input, resistance would be output. Are we okay with that?
Yes, we are.
No. Okay.
You're not?
No, not at all.
All right. Work output.
Oh, are you using this formula, but you just like already changed it up?
Well, what is work? Work is force times distance, right?
Well, I'm just saying, like, you have this on this worksheet, and you just already plugged it in and flipped it.
Okay, let me start back up. Efficiency is equal to work output over work input times 100. Do you see that one?
Yes.
Is this one over there?
Yeah, that's that one right there. All right. Now, work is defined as being force exerted times the distance, right? Now, if I'm talking about work output is going to be a resistance force times the displacement resistance. And work input will be defined as effort force times effort distance.
Because effort is input and resistance is output.
Say that again.
I was just talking about that.
Okay. Does that help?
Just goes completely with the little letters.
Okay. Well, this is your first day seeing these letters, so I can understand that. Can we go on from here? Okay. Now, 0.785. Again, I don't have the times 100 anymore because it was 78.5%. So getting rid of the 100 just made it 0.785. And also, mechanical advantage and ideal mechanical advantage don't have units with them. Because what happens is you end up with joules over joules, and joules cancel out. So there are no units attached with what we're doing here. Now, what is my resistance force here? It says 85 newtons is attached to the wheel and displaced by an effort of 275 newtons, right? So 85 newtons is going to be my resistance force. And my effort force is going to be 275 newtons. Right?
Yes.
Okay. Now, what about my distance? My distance says that it's going to be 8 times 10 to the negative second times 3 revolutions. All right, 8 times 10 to the negative second is my diameter. And what's happening on this is it's rotating around a wheel, and that wheel has a radius of 0.04 of a meter, or you could say 4 centimeters. So we're dealing with a radius of 4 centimeters on this wheel. Now, as it goes around the pulley, what it's doing is it's traveling the circumference of that pulley. You have it attached, it's along the edge, so the distance it travels, if it travels 1 revolution, the distance it's traveled is 1 circumference of that pulley. I'm getting some interesting looks. See, if it makes 1 rotation, let's say that that's circumference there, then the length that it'll go down here will be equivalent to C. I can't read y'all right now. Huh? Yeah.
It looks like a pillar or something. I think we should push it through and then see once we get the solution.
The wheel and axle, you're using a larger to pull a smaller. What?
It's like a donut.
Let me see if you got an example of a wheel and axle. Look, an example of a wheel and axle is C on the top of page 269.